TA angle R congruent to angle X, Y, angle D, and then segment. Remember, you're using congruent, so you need the symbol above it, right? Congruent to AX, Y, congruent to XD, say TY, congruent to AD. Everybody have something like that? If you had put them in a different order, as long as they're corresponding, you're fine. Okay? Oh, let's take a look at what they're doing down here. Oh, by the way, this is important up here. Just forgot. Corresponding parts of congruent triangles are congruent. You see this abbreviation, CPCTC? You need to remember that. Okay? So we're doing proofs. That's going to be a reason. So proofs are, you got to prove some geometric theorem, right? And you have a column of statements, and every statement has a reason that goes next to it in the other column, right? To justify why you made the statement. You'll see what I mean when we get to that. But this is going to be a big one here. So CPCTC, what's that stand for? Yeah, good. Everybody else together. That was beautiful. You all, of course? No, you can't. Okay? Are you? No? What did you say you were? Oh, it was. Past tense. Okay. All right, let's look at this down here. So they're going to do a reflection, right? Every xy maps to x negative y, right? So if you're changing the sign of the y, what's the reflection line? Think about it. If you're changing the sign of all the y values of these points, so here they are in the y, and you make them negative, but just the y's, what line are you reflecting? Not x equals 0. Y equals 0 or what? Or y equals 0, right? And they are congruent. So what does C map to? Angle C maps to what? Angle D. Angle A maps to angle, okay? Because those are rigid transformation. How they're doing the translation, same thing, right? Everything maps. You get the idea, okay? This one here is a little different, right? So they switched the x and y and made the y negative. Well, what would that do to the figure? What transformation would that be? A rotation, right? Which way? Positive 90-degree rotation about the origin. And all of those corresponding parts map to each other. Things are congruent. So the corresponding parts are congruent, which means they have equal what? What? Measure, numerical measure. Okay. Over on the next page here. Let's see. They want to know, are the triangles congruent? Get this one from here to over here. What was the first thing they did? Are they still congruent? And then what did they do? Right 4, down 4. Are they still congruent? And all the corresponding parts map up, okay? Because they use rigid transformations. All right. I think you get the idea here. Let's skip this part here. Let's go down to number 4. So let's see if we can name the transformation that maps one onto the other, okay? In this first one here, think about it, going from triangle ABC to DEF. It'd be a reflection over the what? What's that? Over the y-axis, right? So it went here. So reflection over the y-axis. What's another name for the y-axis? Yeah, there we go. X equals 0 line. And then a translation of what? Let's do a vector. What would the translation be? Okay, give me the vector notation for that, 6 down. Did it go left and right at all? So what goes first? 0, comma, -6, right? Okay, so triangle ABC is congruent to triangle what? Let's get the corresponding parts right. What? Light up. D, then E, then F, right? Oh, good. We have a little triangle somewhere. Let's look at the other one. So we start with triangle ABC. Look, starting over here. Be careful, right? You might have a tendency, oh, we're going left to right. Not always, right? It's not, we're really reading the book here. So we start with this triangle and end up with this purple one over here. So they started with a reflection over the what? Okay, so they reflected it over the x-axis, right, to get it kind of upside down, like that, I guess, over the x-axis. Give me another name for the x-axis, the line. Yeah, you guys are getting that. And then a translation of what? What do you think? Let's just do that. So they were going to A prime, right? That would be like that and that. Did I get that wrong? That doesn't seem right.
Yeah, I feel it's
Yeah, I missed it. So 1, 2, 1, 2. There we go. So, yep. Oh, is that right now? Okay. Yeah. Okay, so we got the reflection, right, over the x-axis. And then what was the translation of? -4, 0. So you count 1, 2, 3, 4. Does this point here, that's C prime, does that map to the G there? So be careful.
You have to look left to cap.
I don't think so. Besides, they said translation. No, say it's translation. What's the translation? How many units? Which way? 13? 11? Positive 11? Negative 11, comma what? Negative 11, comma 0. Now the congruent statement. Triangle ABC congruent to triangle what? Get the parts lined up. TGH. Wouldn't A, and this is my A prime, right? Wouldn't that go with the T, right? And then the B, this is the B prime. That would go, right? So T, G, H. It could be a little tricky sometimes, matching them up, okay? All right. Quickly here, you guys remember the Pythagorean theorem? We're going to need that. Yes, you do. Oh, come on. When you have a right triangle, C squared equals A squared equals B squared. Oh, yeah, the Pythagorean theorem. We're going to use the heck out of that. It's going to be a useful tool in our tool belt. Okay? So we'll review it. This is not going to be anything new. Pythagorean theorem. Okay? So let's say I have a right triangle. There's my right angle. Okay? Call this side A and that one B. And this long side, anybody know the name of that long side? Right triangle?
Along the line.
Starts with an H. Hypotenuse. The long side of right triangle is a hypotenuse. Sometimes it's kind of tough to tell which one's the longest side, right? But the hypotenuse, everybody listen carefully. The hypotenuse, you see this right angle here, is always across from the right angle. The side across from the right angle is called the hypotenuse, okay? The other two sides are just called legs. That's a leg, that's a leg. All right? You know how to identify the hypotenuse, the longest side? If the stuff tells what the longest side is, it's the side across from what? The right angle, okay? So if we have a right triangle set up like this, we've labeled it A, B, and C. We have C on the hypotenuse. This is the Pythagorean theorem. Well, let me just state a little bit more formally. Yeah. So if right triangle, I'm starting to abbreviate now. I'm going to do a little if-then statement because all mathematical theorems are if-thens, right? Conditional statements. If right triangle, then c squared equals a squared plus b squared. Okay? You're probably used to seeing it as a squared plus b squared equals c squared, right?
Mhm.
Yeah. Does it make any difference? Because you can switch equal signs around, doesn't really matter. But put it this way is going to be more useful for us. But I mean, we'll use it the other way sometimes, but it's going to be more useful for us to put it this way. So let's just do a quick example. Maybe two. What do I have? So if I have, okay, let's call that, what do we got? Yep, okay, 5. We'll make that a 12. And I'll just label that C as the variable there. Doesn't have to be C. Anything probably could be an X or a Y or a Z or something like that. Okay. All right. So we know that this hypotenuse squared equals the sum of the legs squared, right? Sum of the legs squared. Okay. So we know that C squared equals 12 squared plus 5 squared. And by the way I'm doing this math here is the way I want to see everyone doing it. Okay. I'm going to work nice and vertically, right? Top to bottom. I'm not going to scatter crap all over the place, right? Because you always want to do your algebraic work like someone else has to read it and understand it, okay? It's like writing an essay, right? There's certain rules that you use to make it readable to other people. So what's 12 squared? 44 plus 25. Add those up. What do you get? 169. Are we done? We don't want C squared, we want C, right? What operation? What operation undoes squaring? Square root. So we'll take the square root of both sides, right? So we'll just go square root of C squared. What's the square root of C squared, guys? C equals square root of 169. 13. Okay? We'll circle your final answer. So my work looks nice and neat, top to bottom. Okay? It's like I'm telling a story. Those are sentences. That's a paragraph, isn't it? Right? Like I have a full sentence, right? Here's my subject, C squared. The story's about C squared, right? There's my verb. So noun, verb equals, right? This stuff, direct object. You remember learning that in English class? Sentences. They have the subject, the verb, and a direct object. Well, it's not really a sentence. Todd's Learning Center problem, right? Okay. Let me give you another quick example here. Just do, let's say, wording it a little differently, maybe, I don't know. So let's say we do hypotenuse 5. I'm going to have that, yeah, 3. I'm going to use an X here instead of A and B. Somebody give me an equation to solve this for that leg there, X. You got the Pythagorean theorem up here, right? So you're just replacing the stuff in this, you're just replacing that stuff with what it is in the triangle I gave you. So replace that stuff with this stuff. And what's the equation? X squared. Careful now. In this theorem, you see this thing that's all by itself on one side of the equal sign? That is always the hypotenuse. You got me? Whatever the hypotenuse is, whichever way you write this, right? The way you learned it first or this way, whatever the hypotenuse is that thing here that's all by itself. So is it going to be x squared equals? 5 squared equals what?
X and the 3.
X and the 3? X plus 3? You're not going to square anything? Why not?
Oh, it's squaring it.
Yeah. Let me just do this. X squared plus 3 squared equals 5 squared. Why did I switch it around? I got a little quick. You notice I switched it around? Here's my a squared plus b squared equals c squared. This is my thing. I have to have my variables on the left-hand side. It's just me. Okay? I can't stand getting done with a problem and I have, like 17 equals x. It's backwards, right? And it works. It's fine. Do All right, so let's work this through. What's 3 squared? Equals 25. What do we do to both sides? Subtract 9 from both sides, leaving us x squared equals what? What? 16. Notice I don't need, at this level, guys, you don't need to do the -9 underneath, okay?
Oops.
And you don't need to draw a line down your equal signs either, okay? Just take the trading rules off here. It's big kids, all right? And now what do? What's x equal? Take the square root of both sides. X equals what? 4. Okay? All right. So we're going to need that Pythagorean theorem. Know how to use it. Let's go look at it and read it now. How many reading questions do you see in this section? A lot more than we usually have, right? So what does that tell you about the people that make this reading exam?
They make more practice like this.
They like this stuff, okay? So let's focus on this. So let's take a look at the first one. Read that. Easy. A little smaller. Counterclockwise, about point X. One triangle maps to the other, right? So to figure out what parts go with what are you going to look at, guys? Because it's like, look at those 2 triangles. They have like a distinct shape, like one side really pointing out right. You can't really identify them. So what are we going to look at to figure out what parts go with what parts? Well, you mean this, the way they're oriented? What you meant? Yeah. Okay. So think about it. One of those statements is true. So, by the way, when you see this ABC maps to triangle RST, what does that tell you about the 2 triangles? One maps to the other. They're congruent, which then means all their what? Get right, corresponding parts are congruent, right? Okay. So, what's the answer? Say choice 1. So here's A. It lines up with R, right? So yes, that's got to be it. Okay? Let's go to number 2. Notice what they give you here, right? So you think choice 2, reflection over the y-axis followed by a translation. Well, what told you there was a reflection involved? Okay, the orientation got reversed, right? So it's got to be choice 1 or 2. Well, do we know it? Let's see, reflection over the, okay. Can we reflect it over the x-axis and then translate it and get it over to the, which way? We're starting with what, ABC? Yeah, sorry. Can we reflect over the x-axis and then get it to line up with that, map up with that? No. So we got to reflect it over the y-axis, right? Yeah, it'd be upside down. And then translate it. So it'll be choice 2. All right? Move it along. Read over number 3. And always read them carefully. Can we narrow it down to 2 of the choices right out of the gate? Why? You check the orientation, right? Okay, so it's 3 or 4. Which of 3 or 4 is it then? 4. Reflection, and then clearly it was rotated, right? Good. Got you getting this. On to number 4. Make them bigger or smaller, keep them in shape. If they're congruent, could they be similar? Remember scale factor? Was there a dilation or a particular scale factor that made something congruent? Scale factor is 3 times bigger, right? Scale factor is 1/2, it's half the size. What's the scale? Is there a scale factor for dilation? make things congruent. We talked about it. What? One, right? So we dilate it, so dilation makes things similar, but at the scale factor of 1, they're also what? Congruent. So what do you think about the answer here, number 4? Gotta be choice 1, doesn't it? Okay. Is anything that any two things that are congruent, and probably should have saved this question for when we did similar stuff, but I think we got it right. Any two shapes that are congruent are also similar with a scale factor of 1. Okay? All right, on to number 5. This is going to require a little bit of mathematical work, okay? A little bit of algebra. That's why you take algebra for this class. You do some stuff. So can someone tell me if the two triangles are congruent? Yes or no? Are they congruent? No? It says ABC mapped onto DEF after some rotation. I thought rotations were isometric. So are they congruent? So that statement tells you have two congruent figures. And what do we know about congruent figures and their corresponding parts? What the corresponding parts are. Huh? Well, they're congruent, which means they have equal numerical measure, right? Okay. We want you to find a value for x. So the figures are congruent. You know, corresponding parts are congruent, having equal measure. Does that help us get an equation to set up and solve for x? If two things are equal in math, what do we put between them? An equal sign. So what two things are equal here? So the x is here in DE, right? So DE corresponds to what in the other triangle? See how I'm using my statement here? What's the length of AB? So somebody give me an equation. 2. Yeah, but I like my variables over here. Everybody see how we did that? Figures were congruent, so the corresponding parts are congruent. They got a variable there, which means we need an equation. And knowing that two things are equal, we put an equal sign between them, bam, we're back to algebra. Okay? You can solve this, right? Subtract 1 from both sides, you get 2, or add 1 to both sides. 2x equals 17. Divide by 2. What's x equal? 8.5. All right, there we go. Number 6. Everybody see this here? Not. What do you think? Why is 1 not always true?
Because B and C provide E.
You're looking at this, right? That should go with EF, right? So this is the one that's not true. Good job. All right, just catching this now. Number 7. Now we'll have to do some writing. Because it says sequence, so it can't just be 1. Any thoughts? Yeah.
Reflection over the y-axis.
Okay, let's try it. So let's reflect it over the y-axis. 1, 2, 1, 2, right? And then B over here, and then A, and the, where are we? Right there? Here. Right? Like that. So here's my B prime, C prime, A prime, right? Okay, I'll buy that. And then what? Okay, be specific. Down 2, right? So let's say then we did a reflection in y-axis, then translation down 2, right? Oh yeah, there's more. And maybe there's some other ways, there's probably other ways you can do that, right? I don't know, what's the different right answers there? That's a good one. Number 8. Now, number 8, you think seriously about the kind of answer you get for this one, right? It's kind of a question we have to see a couple like this. So not so robust answer. Anybody think about what the transformation was? Well, it's got to be more than one, right? What do you think happened? Okay, reflection in the y-axis probably, right? So then go like that, and then C, and then B, like this here, you mean? And then what? Like 3? Or exactly 3? Okay, all right. Yeah, it's going to map onto it, right? Did we start? Ooh, uh-oh. Look what I did. What did I do wrong? Started the wrong one. Be careful, children. Yeah, I see that. I might have to pause it here and start up a part 2. Okay, so let's reflect the proper one. Let's start with the proper one first, right? So we got A, and then B's over here, and then C is going to be right here, right? Okay. So that guy there, and then what did we do?
Down.
Huh?
Down 3.
Down 3 now, right? Okay. So the question is A prime, B prime, C prime congruent to the triangle ABC?
Yeah.
And they said use properties of rigid motion to explain your answer. So let me just give this. So we're going to say yes. You got to have either yes or no. Yep. Okay. And we did a reflection and a translation, right? Didn't we? So reflections and translations are what kind of motion? So reflections and translations are, we could say isometric, but let's use the word they used, right? Are rigid motions, right? Okay? As I said, use properties of rigid motion to explain your answer. What we're about to do. Are rigid motions, so what can we say about the triangles? The triangles are the triangle apostrophe S are congruent. Okay? Does that make sense? Okay, let's move on to number 9. I'll have to do like a part 2 video. It's getting too long.